going to walk you through the first part of the friction problems. So number one, a 10 Newton force is applied to a 25 kilogram mass to slide it across a frictionless surface. Draw a free body diagram. What are the three forces acting on the mass? So let's go ahead and draw our free body diagram. Here's our table. We always have gravity when we're on the planet Earth. We have a normal force that should be equal and opposite. And then we have an applied force that we're pushing. There's no frictional force. If you did have a frictional force, it would be here, but it says that it's frictionless, so we don't have that force. So here is our free body diagram. What is the acceleration of the mass? Is it speeding up, slowing down? If there's no friction, no math needed. Well, if there's no friction, then we are going to be speeding up, and the reason is we have unbalanced forces in the left-right direction, and anytime you have unbalanced forces, you have an acceleration, and in this case we're speeding up. Number two, a 25 Newton force is used to push a box across the floor against a frictional force of 14 newtons. The box accelerates from rest to a speed of 4 meters per second in 16 seconds. Okay, we have a lot of information here. We're going to start with a free body diagram again. So let's get the four forces acting on the box. Oop. Here's our floor. So we have gravity and normal. Those are equal and opposite and balanced in the up and down direction. Box is not moving up, box is not moving down, it's balanced that way. And then we have 25 newtons, we'll say to the right, and then we have a frictional force to the left of 14. So we have a force applied of 25 newtons to the right. And I'm going to draw this one a little bit shorter because it's less than 25. We have a force of friction of 14 newtons to the left. So actually I'm going to call that negative because it's to the left. So our free body diagram would look like that. What is the acceleration of the box? Well, before we figure out the acceleration of the box, we need to find the net force first. So let's go ahead and find the net force by adding together the forces in the left-right direction. So I have 25 newtons plus a negative 14 newtons, and that gives us 11 newtons positive. So we have an 11 Newton force to the right. We're going to find the acceleration of the box next. So let's go ahead and using this equation here, we're going to go ahead and put acceleration, change in velocity, and time. So acceleration is what we're looking for. Our change in velocity, it says up here we went from rest to 4 meters per second. So from 0 to 4 gives us a change of 4 meters per second. It says it took 16 seconds. So we're going to go ahead and solve for over 16 seconds. We can figure out the mass of the box now by finding, using Newton's second law. So I've got F net, I've got mass, and I've got acceleration. F net equals m times a. We've just rearranged it for you here. So our F net, like we solved before, is 11 newtons. We're looking for the mass of the box, and we know our acceleration is 0.25 meters per second squared. So we're going to take 11 newtons divided by 0.25. So 11 divided by 0.25 is 44, and our unit is kilograms for the mass.